Hey everybody, just want to welcome you to week 7, module 7 for ME111 System Dynamics. So this week we have a couple things going on. First, your quiz 7 has been posted to Blackboard. This will be due on Friday the 16th by 4 p.m. Next, we have your homework 3 has now been assigned. So this will be released October 12th at 6 a.m. and it'll be due Monday, October 19th by 11 p.m. Again, please reference the homework guidelines for details on formatting, grading, and submission. At this point, you've already done 2 homeworks and an exam, so you should have a good idea of how we're grading these and what we're expecting as far as the format goes and as far as the rubric goes for grading. If you have any questions, though, that you can't understand from the guidelines, please feel free to reach out. Again, my office hours are Tuesdays and Wednesday mornings from 9:30 to 10:30 a.m. But if this time doesn't work for you, just reach out for me via email or send me a chat on Teams, and we'll pick a time that works well for both of us. So as we get into Module 7, we're going to be looking at fluid and thermal systems. So some objectives for this chapter here. Once you're finished, you should be able to apply the conservation of mass principle to model simple hydraulic and pneumatic systems. You should be able to determine the approximate resistance relation for a laminar, turbulent, and orifice flow. You should be able to develop a dynamic model of hydraulic and pneumatic systems containing one or more fluid containers. You should also be able to determine the approximate thermal resistance relation to use for conduction, convection, and radiation heat transfer. You should also be able to develop a model for the thermal process having one or more thermal storage compartments. And last, we're going to look again at MATLAB and Simulink to solve for fluid and thermal system models. So we're going to break this module down in a couple different sections. The first section will be our 7.1. In this section here, we're going to look at fluid systems. So relating back to our textbook, this will be section 7.1, conservation of mass, 7.2, fluid capacitance, 7.3, fluid resistance, 7.4, dynamic models of hydraulic system, and 7.5, pneumatic systems. So a fluid system uses one or more fluids to achieve its purpose. Next section, we're going to look at module 7.2 here for thermal systems. So this will cover 7.6, 7.7, and 7.8 for thermal capacitance, thermal resistance, and dynamic models of thermal systems, relating back to our textbook. And last section here will be 7.3, and this is where we're going to start looking at MATLAB and Simulink models and applications and go through a couple different examples utilizing those.